Due to length, I cut the previous video, which was Orthophoto from DTM, and we will now continue here with Orthophoto from DSM. Enjoy the video and have fun. So let's hide our data. We will here hide our DTM Ortho, and I will hide my point cloud and my DTM Orthophoto itself. And then we will here use as boundary again the same, so we have the same area covered. We will use digital surface model in high. Oh, I should have changed the name first, but we will see. So let's then output here into our folder. Let's call it this folder here DSM Ortho, and we will run also a high density for our DSM. We will call it in this case here now DSM Ortho, and that's it. Nothing else changes. Let's process and then see the result. So we finished our processing with the DSM setting, and we see now that in the point cloud, that is the DSM Ortho point cloud, and we have the Ortho. And so let's take now a look at these areas that we discussed. So in our case here, this area here where we had with the DTM some mismatches, and now with the DSM, which is denser, also using here and therefore more possibilities to check for mismatches because we have more measurements. So let's jump into the 3D view and take a closer look into this area. And when we take a look here, and let's rotate it a little bit, we can see already here that the point cloud here is nicely on the road. So there are no mismatches, there's nothing here floating on top, mainly because we can here match much more detail, and therefore with the details we can also better filter automatically what is ground and what is not ground. And this will then cause, in our case now here, when we take a look at that our lines are now not shaken. Compare one more time. You remember here was our shakiness, and when we now go here into our DSM point cloud that was used for the Orthophoto, then we can see here that this is now nicely adjusted and fits per road marks in the center. So this is really a big benefit also. And then just to already that we see the known things, you remember here with our our construction here, and just that you are aware, let's here put on the DSM Ortho some slide transparency. I will move it here to 50%, and when we now toggle between on and off, and then you see here that the Orthophoto with the DSM is more like a true Orthophoto. Yeah, so this one is more bending, and this one here is more straight up, and the color is now here. Go back to 0, so that not that you think that this is it's not so good. And so we can here really see how this now here makes really a difference in the true auto rectification, and therefore then the objects are more straight up. And this is really then the advantage also from the DSM point cloud, that these objects then allow us more to look behind areas that are normally occluded because of the leaning effect in the DTM from the point cloud. Gives us more information about the objects. So let's go back into the scan points and into our 3D view. Let me here remove the points here. And then when we take a look here at this construction part here, we can now see that this point cloud here is now much more on top of this construction. And when we here switch off or switch on the other point cloud, then we can see here, this is now not on top of this construction. Yeah, so that means the DTM orthophoto, this one here, is based on a terrain model that is on the ground, and the DSM uses now here these additional points that are here on top, like these ones here, and they will now be used for rectification. The resolution of the orthophoto is identical. That means we have here our 0.089 feet, and in the same, when we take here a look now at our DTM orthophoto, exactly the same. Yeah? No difference in this case here. Same resolution, just based on a different point cloud model. And just again to be aware, having of course the benefit in more complex undulation, terrain change, small creeks, if you have the road drops down to the next part, and this can be in terraces even more extreme, or in mining. So there are many options where a dense point cloud helps us to make our on the correct terrain model. As our DSM orthophoto is based on this dense point cloud, which matches always or tries always to include our single objects like trees, buildings and stuff like that, you see at the edge that this is here more tangled up because our point cloud is not filtered so much. We try really to have the point cloud on top of the trees, and therefore we try not to interpolate or filter out the points to the ground, which is the case for the DTM. So here is, it looks cleaner on the edge. In the end, what happens here, the point cloud is just here interpolated, and therefore because we interpolate it, then it's on the ground. That means we can just, it has all the same heights almost, so this terrain model here is just smoothly going up the hill, ending up here. Well, let me just take a look at this. So here we go. You can see here the point cloud here is smoothly, continuously going to the edge in this case. It's not right or wrong because in the trees we will match some points on the ground, some are intermediate inside. But again, it's really more continuously going to the edge. And when we take a look at the point cloud from the DSM, then we can now see here we have much higher vegetation included here. And because our last photo is taken, let me switch off the scans here, so on the right side of these trees. So these are my last photo images, and let me zoom out here. That means if I look from here, let me switch on the point cloud here again. So that means when we look from this projection, let me try to rebuild it here, for example. Yeah, you see this. If you look at this yellow, this is my exposure, and when I go down, I see there's my tree hiding the content behind it, so I cannot see this area here behind from this image, and this is like occlusion, and therefore I will not be able here to see behind this area. And therefore, when we switch off the orthophoto again, then we don't get here this content auto-rectified, because we have these trees that are used here as our last resort for our auto-rectification, and these points behind here, they cannot be seen. They are cloud area. And the same thing is also for the other parts. So some parts are from these trees here hidden behind it, and that's exactly also correctly geometrically done, and therefore this is the result we get. We don't clean this up by cutting here something more off. This is really what you can do with the boundary. Yeah? So the boundary, I could define a boundary here in a better way. And if you say, okay, Thomas, why can we not make it better? Well, flight planning would have been here the right way. You should have flown with this. Let me here switch it on. You should have flown here. If this is of interest for you, you should not stop the flying here. We should have also continuous our flight till we reach here this area, so we can look from the left side into it. Yeah? So we cannot do magic. Everything what an image can only see, we can extract. And for our goal here, the road is the main target, and the road is very nicely covered. Let's take a look at our project folder. As mentioned, the GeoTIFF is stored in. They are of same size, so the DTM and DSM are here having the same amount, because even photo content here in this area here, but it's still an orthophoto written. Yeah, these are just black pixels. Yeah, but the orthophoto is the same extent. It goes to this purple or violet line, and therefore it has the same dimension in this case. The point clouds are in our folders that we defined. So in the DTM we had our point cloud, which is 4.7 megabyte, and in the DSM Ortho we have now here our point with 900 megabyte. So a big difference that is here done, and also time-wise this is of course taking longer to match it. This is shown in the point you can consider about it. Some information about accuracy. I mean, we have here the control points. We can here of course zoom into our control point areas and see how well the white triangle is fitting on. Here check if they are pinpointed to the position or not, and therefore this is one thing that we can do. And of course here, very common, it's to overlay reference data. If you have some DWG files or any vector data that is from your project, of course overlaying it to the orthophoto, comparing how good, if you have digitized somewhere the road, or if you have here if there would be some constructions and you would have from footprints from the buildings, then you could here overlay them and check then how good the orthophoto fits to the reference data. Okay, so this ends now the DSM orthophoto generation, and we cut here the video. We will have another video about the DSM HQ production. And so sorry for the audio issues in this video. Hope this will not continue this way. I hope you enjoyed the video and wish you a nice day and have fun. Goodbye.